In 12.1, we're going to be looking at functions, and compositional functions. The way we're going to read this thing I here is going to be f of g of x. It can even be written as f of g of x or f on the outside and g of x on the inside. We're going to take a look at practice, and those are basically used in the real world, kind of like when we go get discounts. So there's an example in the PowerPoint, an example when is this used. But now we're gonna get to work on this. So f of g of 4. F of x, the function f is gonna be x squared. The function g, we're gonna do x plus 3. So the way I'm gonna start from the centered g of 4. G of 4, I'm looking at the function g, and I'm saying the variable is 4. So I'm looking at that as 4 plus 3, because I'm looking at g. So g of 4 is 7. So once again, the centered is 7. Now the way I'm going to work this, I'm going to say f of 7 because I just did g of 4. I'm going to do f of 7. So now I'm looking at the function f and the variable is 7. So I'm looking at this as 7 squared, which is known as 49. So f of g of 4 is equal to 49. Now let's take a look at what if I switch the g and the f. I'm going to use the same f, I'm going to use the same g, but now I'm going to start with f of 4. I'm going to do the center, which is f of 4. So f of 4 is the same thing as 4 squared. I'm using the function f, and the variable in this case is 4. So 4 squared is 16. So I'm going to say f of 4 is 16. So now I'm just going to do g of 16, which is 16 plus 3, better known as 19. So g of f of 4 is equal to 19. So again, we work the center first and then we work our way out. One thing that we want to emphasize though, f of g of 4 was 49, g of f of 4 was 19. So the order does matter. So don't think that because you're using f and g of 4, you always get the same answer. Now let's take a look at another example. Now we're going to switch the values of f and g. We're going to start with g of 2. So I'm going to use g. My variable is 2. So g of 2, I have 2 squared plus 5, better known as 9. So g of 2 is 9. Now I'm going to do f of 9. Now I'm using the function f. So I have 4 times 9 minus 1, 36 minus 1, which is 35. So my answer in this case is 35. Now let's take a look at b. Here I'm saying g of x. So I'm going to create a function, g of x. Now, g of x is x squared plus 5. What that means is leave x as the variable. Okay, so that's as much as I can simplify. Now I'm going to do f of x squared plus 5. So I have that 4 times x squared plus 5 minus 1. Once again, I'm using the function f, and my variable is x squared plus 5. Get rid of parentheses, so I have 4x squared plus 20 minus 1. Right. Simplify by combining your like terms, I have 4x squared plus 19. Now looking at C, it says f of g of 2. On B, when we left it as an x, that's going to work for every f of g as long as we're using this f, the same g, f of g of any value. So here it says use rule in B. So f of g of 2, I'm just going to use 4x plus 19, 4x squared plus 19, but my variable is 2. So I have 4 times 2 squared plus 19. I know I have to do exponents before I multiplied. So I have this as 4 times 4 plus 19, which is going to give me 16 plus 19 or 35. Want us to see that on A, we did f of g of 2 by working g of 2 first. On C, we did the same question, but we're using the formula from B. Now for D, we're going to do f of x first. So I'm going to do 4x minus 1. That's what f of x is. I cannot simplify it because I don't know what x is. So now I'm just going to do g of 4x minus 1, which I'm going to do 4x minus 1 squared plus 5. On the squares, I'm going to do 4x minus 1 times 4x minus 1 plus 5. Get rid of parentheses by doing FOIL, by distributing. So I'm going to have 16x squared minus 4x minus 4x plus 1 plus 5. Now to simplify, just combine your like terms, and I'm going to call this 16x squared minus 8x plus 6. It's easier when instead of x we use a number, but this is how you do composite of functions.